Hello, math study students of mine. Welcome to our 7.1 notes over arithmetic sequences. So let's first of all talk about what a sequence of numbers is in general. A sequence of numbers is simply a list of numbers, and that list can be either finite or infinite, arranged in any order that obeys some kind of a rule. Now, we'll be looking at a couple of different kind of rules. Today we'll be talking about an arithmetic sequence, and in a day or two we'll be talking about a geometric sequence. But in a list of numbers called a sequence, each number in the sequence is called a term. Okay, so let's look at an example. Kenneth decides to put $10 in a vacation fund in January, $15 in February, $20 in March, and $25 in April, and so on. He continues this practice all the way through July. So the first thing we're going to do is write down this entire sequence. Well, the first term of this sequence would be 10, so let's write that down, $10. All right, and then the next month in February, he puts $15 in that fund. Then in March, he puts $20 and then $25 in April. Then the sequence would continue in May, $30. In June, it was $35. And then finally in July, it was $40. So let's write down the first and the last term of this sequence. Well, we can see that the first term is 10 and the last term is 40. So first term is 10 and the last term is 40. Okay? The next thing we're going to do is write down the common difference between consecutive terms. Now, consecutive just means two terms right in a row. So if I want to find that common difference, all I have to do is take any term and subtract the previous term. So for example, 15 minus 10, or 20 minus 15, or 25 minus 20, you'll see that that common difference is always going to be $5. All right, so this scenario above, this example we were just looking at, is an example of what we call an arithmetic sequence. Arithmetic sequence. And the reason why it's called an arithmetic sequence is because there is a common difference between the terms. Okay, note, the common difference can either be positive or it could be negative. You'll notice that in this example, each number was larger than the number before it. So that would be an example where our common difference is positive. But if we had a sequence where each number was smaller than the previous term, then that would have a negative common difference. So let's look at some examples here. It says, find the common difference for each of the following sequences. Well, if our sequence is 2 and then and then 6 and then 10, 14, 18, and 22, you can see that there's an increase of 4 each time, plus 4, plus 4, plus 4 every time. So that common difference is positive 4. Notice the common difference is positive, and each time the terms get larger, okay? How about letter B? So if you look at these common difference from negative 13 to negative 6, and then negative 6 to 1, and then to 8, 15, you can see that that common difference is positive 7, okay? Letter C, notice that these numbers get smaller every time. So since they get smaller every time, our common difference would be negative. We would be subtracting 10 as we go from one term to the next term. And then letter D, we have negative 5, then negative 5.1, negative 5.2, negative 5.3, and so on. Now, on a number line, if you were to look at these numbers on the number line, those numbers would be moving to the left. So these numbers are decreasing, so we have a common difference of negative 0.1. Letter E asks us, which of the above sequences are infinite sequences? Well, if you look at the four examples, B and C are infinite sequences. So we're going to say B and C. And how do we know this? We know that they are infinite sequences because of this ... That ... says that this sequence would continue on forever. Whereas notice A and D don't have the dot, 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 so therefore those are finite sequences. So how do we know that this infinite sequences are infinite? Just put dot, dot, dot. All right, so now let's look at our first formula of the day. And this formula is not one, we're going to use it a lot, but it's not one that you'll need to memorize because it is on the Math Studies formula chart. But we're going to look at the formula to find the nth term of an arithmetic sequence. So that formula is u sub n equals u sub 1 plus parentheses n minus 1, close those parentheses, times d, where u sub 1 represents the first term of the arithmetic sequence, n is the number of terms, and d is that common difference. Common difference. Okay, so let's use this formula and take a look at an example. So our first example says, here's a sequence of numbers, 2, 5, 8, 11, etc. And part A says, show that the sequence is an arithmetic sequence. Well, to show that it's an arithmetic sequence, all we need to show is that there's a common difference. So let's go ahead and list the terms of the arithmetic sequence. We have 2, and then 5, and then 8, 11, 14, 17, etc. That goes on forever. So you'll see that common difference, if I take 5 minus 2, I'm going to get 3. So there's a difference of 3 between the first and the second term, a difference of 3 between the second and third, and so on. You'll see that this pattern continues. Okay, so showing that common difference is how we're going to show that this is an arithmetic sequence. Letter B says to write down that common difference. Well, notice each term gets bigger, so there's a common difference of positive 3, so D equals 3. And then letter C says find the 10th term. So here's how we're going to use that formula. So let's start by writing the formula down. U sub n, which is the nth term, is equal to the first term, u sub 1, plus the number of terms minus 1 times d, which is the common difference. So to find that 10th term, u sub 10, we're just going to take the first term, which is 2, plus, remember n, let me grab a different color here. This is n, right? That's n. So when I take n minus 1, that would be 10 minus 1, which gives us 9. So we just need to take 9, whoops, let me change that color, 9 times the common difference of 3, and then do that arithmetic. You can either do it by hand or on a calculator, but you'd get 29. So 29 is the 10th term. And then letter D says find the 25th term. So to find the 25th term, we're going to use the same formula again. U sub n equals u sub 1 plus n minus 1 times the common difference. So that 25th term would be the first term, which is 2, plus this time n is 25. So n minus 1 would be 25 minus 1, or 24. So that's going to be 24 times our common difference of 3 again. Do the arithmetic, and that 25th term turns out to be 74. Okay, let's take a look at this next example, which says the second term of an arithmetic sequence is 1, and the 7th term is 26. Letter A says find the first term and the common difference. So you'll notice we don't know either the first term or the common difference. All we know is the second term. We know that the second term is 1 and the 7th term is 26. So since there are 2 unknowns here, I need to find the first term and I need to find the common difference. 2 unknowns means that we're going to have to write a system of 2 equations and 2 unknowns. So let's start with our formula for the nth term. U sub n is equal to u sub 1 plus n minus 1, the number of terms minus 1 times the common difference. All right, now let's write 2 equations. So let's start with 1. Remember, we were told that 1 is the second term, so that's actually u sub 2, isn't it? And 1 is equal to that unknown first term plus, remember, n is 2, so 2 minus 1 would be 1. So we're just going to write 1 times d. So that's our first equation, okay? For the second equation, let's use the fact that 26 is the 7th term. So 26, which remember is our 7th term, that would be u sub 7, is equal to that unknown first term plus n minus 1. So in this case, it would be 7. 7 minus 1, which is 6. So we get 6 times d. So now we have, here's our system of two equations with two unknowns. And that's going to be pretty easy to solve. We can solve it using elimination just by subtracting the two terms. That would make the u variable drop out. So 1 minus 26 gives us negative 25. The u's drop out when we subtract, and then 1d minus 6d would give us negative 5d. And dividing both sides by negative 5, we get that our common difference is 5. So we know one of our unknowns, the common difference is 5. Now let's go ahead and find u sub 1. So I'm just going to take this first equation, okay, and I'm going to replace d with 5. So that would be 1 equals u sub 1 plus 5. I'm just replacing d with 5. Subtract 5 from both sides, and we get u sub 1 is negative 4. So we have found our common difference, and we have found the first term. So that takes care of letter A. So now let's move on to letter B, which says find the 100th term. So let's use that equation for the nth term. So u sub n equals u sub 1 plus n minus 1 times d. So to find that 100th term, that would be u sub 100. That equals the first term. Remember, we just found out that our first term was negative 4. So that's going to be negative 4 plus n in this case is 100. So when we take 100 minus 1, that's going to be 99. So 99 times that common difference. The common difference, remember, we found out in part A was 5. So that's times 5. And then do the arithmetic, and we see that the 11th term, no, not the 11th, excuse me, the 100th term is 491. Our next example says, here's a sequence of numbers, 6, 10, 14, ... 50. It says write down, letter A asks us to write down the common difference. So that's pretty easy. If we look, as we look from one term to the next, or take any term and subtract the previous term, you can see that that common difference is 4. So for letter A, we're going to say that D is equal to 4. Then letter B says, find the number of terms in this sequence. So let's start with our formula for the nth term. U sub n is equal to u sub 1, the first term, times n minus 1 times d. Common difference. So we know that our nth term is 50. Now we don't know if that's the 10th term or the 50th term or the 60th term. We just know that whatever n is, we know that u sub n is 50. So we're going to say that 50 is equal to our first term of 6 plus, remember, n is the number of terms, and we don't know that. That's what we were being asked to find. So we're going to have to leave that variable in our equation. N minus 1 times the common difference we found in part A was 4. All right, so this is a pretty simple equation to solve for n. We would get 50 equals 6 plus 4n minus 4. Now I'm going to subtract 6 from both sides and add 4 to both sides. So 50 minus 6 is 44, and then plus 4 would be 48. So we get 48 is equal to 4n. Divide both sides by 4, so n equals 12. The number of terms is 12. Okay, the second thing we're going to talk about today is the sum of the first n terms of an arithmetic sequence. Okay, so first of all, the sum of the first n terms, we write it like this. The sum of the first n terms we write as capital S sub n. So the capital S stands for sum, and the little n, the subscript of n, is the number of terms. So when we add up a finite number of terms in an arithmetic sequence, that is called an arithmetic series. Arithmetic series. Okay, so if we have an arithmetic series S sub n, so that would be our first term u sub 1 plus the second term u sub 2 plus the third term u sub 3 plus the fourth term u sub 4 plus dot 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 all the way up to the nth term. So that would be plus u sub n. Okay, so we have a formula, actually a couple of different formulas that we're going to use for finding the sum of the first n terms of an arithmetic sequence. Okay, so the first formula for the sum of the first n terms of an arithmetic sequence we're going to use, or we're going to learn, is a formula that you use when we know the first term and we know the last term. And that formula looks like this. It is S sub n is equal to n divided by 2, the number of terms divided by 2, times the first term plus the last term. So if we have that information, if we know the first term and the last term, then this is a pretty easy, and we know the number of terms, this is a pretty easy formula to use. But sometimes we don't have all that information, so we have a second formula. This is the formula for the sum of the first n terms of an arithmetic sequence. We'll use that when we know u sub 1, which is the first term, and the common difference. So for that formula, it is equal to n divided by 2 times 2 times u sub 1 plus n minus 1 times d. So let's identify all these parts of these formulas. So u sub 1 will always represent the first term. Okay, n always represents the number of terms, and u sub n represents the nth term. Okay, so let's look at our first example. It says the first 4 terms of an arithmetic sequence are 5, 8, 11, 14, etc. Calculate the sum of the first 80 terms. Okay, so we needed to decide which of these formulas we're going to use. Well, the first one, we need to know the number of terms, the first term, and the last term. Well, we don't know the number. Oh, well, I guess we do know the number of terms. We're finding the sum of 80 terms. We know the first term, but we don't know the last term. So let's look at our second equation. We want to use the second equation when we know the first term and the common difference. So do we know the first term? Yes. Do we know the common difference? Looks like that common difference is 3. So we're going to use that second formula. So let's start by writing the formula down. S sub n, the sum of the first n terms, is equal to n divided by 2 times 2 times the first term plus n minus 1 times the common difference. All right? So we're going to be finding in this problem the sum of the first 80 terms. So that's going to be 80 divided by 2 times 2 times the first term. Well, the first term is 5, so that's 2 times 5, plus the number of terms is 80 minus 1 times the common difference of 3. And so this is arithmetic that you can do on your calculator. And when you do, you should get the sum of that first 80 terms is 9,880. Okay, the next example asks us to find the sum of this series, -3, 1, 5, 9, dot, 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 81. So you'll see we know the first and the last term. So let's start with the formula that uses the first and the last term. It looks like this. S sub n equals number of terms divided by 2 times the first term plus the last term. Okay, so this is going to work except for the fact that we don't know how many terms are in this series. We do know the first term, we do know the last term, we don't know how many terms. But we can find out how many terms pretty easily by using the formula for the nth term. U sub n is equal to the first term plus n minus 1 times the common difference. Okay, so in this formula, let's see if we know everything. Do we know? We don't know. Oh, we do know what the nth. Oops. What did I just do? Let me fix that. Sorry about that. Okay. We do know what the nth term is. The nth term is 81. Okay, we know the first term, it's -3. We don't know n, the number of terms, but we do know the common difference. So that leaves just one unknown of n. So let's go ahead and fill that in. So the nth term is 81, and that's equal to our first term of -3 plus n, remember n is unknown, n minus 1 times the common difference of, let's see, our common difference is +4. So let's solve that equation for n. 81 equals -3 plus 4n minus 4. Let's add 7 to both sides. -3 minus 4 is -7. So let's add 7 to both sides and we'll get 88 is equal to 4n. So n equals 22. Okay, so now we have everything we need to find the sum of, now that we know what n is, we can identify it, the sum of the first 22 terms. So that's going to be 22 divided by 2 times the first term of -3 plus the last term, which is 81. So that's just arithmetic that can be done on a calculator, and the sum of the first 22 terms is 858. All right, so now let's look at some more practical or some more real world type examples. So this next example says Susan wants to buy a flat, that's an apartment or a home. She has to pay for the flat in 20 yearly installments. The first installment is 5,500 euros, and then each installment is 500 euros more than the one before. So that's kind of an unusual setup. Every year she has to pay 500 more euros than she did the year before. Okay, so the first thing we're going to do is write down the values of the second and the third installments. Well, we know the first installment is 5,500, and each year she's going to pay 500 more than she did before. So that means for letter A, that second installment is going to be 5,500 plus 500, which would be 6,000 euros. And then the third installment is going to be $500 more than that, or 500 euros more than that. So that would be 6,500 euros. Okay, and then letter B says, calculate the value of the final installment. So that's the 20th term, because there's going to be 20 installments. So in other words, we're asked to find U sub 20. So using our formula for the nth term, that's going to be equal to the first term, which is 5,500 euros, plus n minus 1. N in this case is 20. So 20 minus 1 would be 19. So it's 19 times the common difference of 500. So do that arithmetic, and it's going to be 15,000 euros is going to be how much? Whew, that's pretty expensive. She started at 5,500. 20th installment is going to be 15,000. And then letter C says, show that, so we're going to have to show some work here. Oops. It says, show that the total amount that Susan would pay for the flat is 205,000 euros. Okay, so let's use our formula for adding n terms. Since we know the first term and the common difference, let's use that second formula that says S sub n, the sum of the first n terms, is equal to n divided by 2 times the first term plus n minus 1, number of terms minus 1, times the common difference. So in this case, we're finding the sum of the 20 terms, and that's going to be equal to 20 divided by 2 times 2 times the first term, which was 5,500 euros, plus n minus 1. N is 20, so n minus 1 would be 19. So that's 19 times the common difference of 500 euros. Okay, so we'll do that arithmetic, and turns out to be 205,000 euros is what would be the total that she's going to pay if you total up those 20 installments. So now let's take a look at our last example. It says the sales of smartphones are growing every year. At the end of 2006, the number sold was 25 million. At the end of 2010, the number sold was 35,800,000. And then assuming, and this is a huge assumption, assuming that the sales figures follow an arithmetic sequence, calculate the following. Letter A says calculate the number of smartphones sold at the end of 2008. So we're going to be looking for an nth term in letter A. So let's write the formula. U sub n, the nth term, is equal to the first term plus n minus 1, the number of terms, minus 1 times the common difference. Okay, so let's see. If we list the years, the first term is at the end of 2006. Then we have 2007, 2008, 2009, 2010. So if this is the end of 2006 is our first term, then we're looking at the second, third, fourth, and fifth term. So what we know here, we're given this 25 million, that's the first term, and this 35,800,000, that's the fifth term. So as we look at this formula, we know what n is, it's 5. We know the first term and we know the last term. What we don't know is the common difference. So let's go ahead and write an equation and solve to find that common difference. We know that that fifth term is 35,800,000, and that's equal to the first term of 25 million plus 5 minus 1, which would be 4 times the common difference. Okay, so subtracting 25 million from both sides, we'd have 10,800,000 is equal to 4 times D. Divide both sides by 4, and that common difference is 2,700,000. Okay, so now what we can do is we can find, now that we know the common difference and we know the first term, we can find, let's see, at the number of smartphones sold at the end of 2008. So remember, 2006, that's our first term. 2007 is the second term. At the end of 2008, that's the third term. So in other words, this, by the way, these 3 dots here, that means therefore. So therefore, U sub 3, the third term, is going to be equal to our first term, 25 million, plus n minus 1. Well, in this problem, n is 3, so 3 minus 1 would be 2. So 2 times the common difference of 2,700,000. Okay, so doing that arithmetic, there would be 30,400,000 smartphones sold at the end of 2008. Okay, so then let's take a look at letter B. Letter B says calculate the predicted number of smartphones sold at the end of 2015. So if I kept listing my years and counting up to 2015, that would be the 10th year. So in other words, we're being asked to find U sub 10. So U sub 10 is equal to the first term, which is 25 million, plus n minus 1. Well, n is 10, so 10 minus 1 is 9. So that's going to be 9 times the common difference, which we found in part A to be 2,700,000. 2,700,000. Okay, so do that arithmetic, and it turns out to be 49,300,000 smartphones. That's a lot of smartphones. All right, so there we go. Now, this homework will be due next time. I'm going to go ahead and place those problems in Google Classroom, so you can go ahead and pull up Google Classroom, pull up the problems, and get started. And if you have any questions, be sure and ask me.